I want to review with you operations with polynomials. That's add, subtract, and multiply. Lesson 8.1 is adding and subtracting. Lesson 8.2 is multiplying. The new thing that we talked about last class is degree of a polynomial. And that really is how many variables are there in a single term. So I'll do some examples here. This is all answered. If you want to pause and kind of look this over for just a moment, I'll talk you through some examples on the next screen. This is all vocabulary that you need to be familiar with. They shouldn't be new. At least they shouldn't be new today because I asked you to look over them last class when you were doing lesson 8.1. So like terms, if I'm combining like terms going forward, I just need to make sure that you know what that is. That means that the variables match. So if I have x's, I put all the x's together. If some of them are x squared, I put those with the other ones, they're x squared. Or if there's constants and there aren't variables, then I put those together. Those would be considered like terms. For polynomials, I name them by how many terms there are. So monomials have one term and binomials have two. Trinomials have 3 terms. Degree of a polynomial refers to how many variables there are in a given term. So this doesn't have any variables. That makes it degree 0. Here I have 4 variables because I have 3 x's and a y. So this is a degree 4. With a polynomial, this is a binomial because I have 2 terms. So for my binomial here, I have 2 terms, one with 2 x's, so that's degree 2, and one with an x, a y, and a z. That's 3 variables, so it's degree 3. So I would say that my binomial is degree 3. This last example is also a binomial because I have 2 terms. My first term is degree 5 because I have an x and 4 y's, which is 5 variables. My second term has 8 variables, so I name my binomial a degree 8 because the term with the highest number is how you name your polynomial. In lesson 8.1, we added and subtracted polynomials. So you combine like terms, and there's a couple ways in the video that I linked for you on Canvas that you can combine them. One is to stack them up on top of each other. So I just match these. The first group and the second group aren't always in the same order. So just make sure that you're combining with something that has a matching set of variables. Okay, so I've transferred these over and they line up so that I can combine like terms, and I need to subtract these. What I would like for you to do just to make it less likely that you make an error when you're subtracting, is to distribute this -1 into the parentheses. So I need to change the sign of everything inside the parentheses there. Once I do that, I can add. I can change this to a plus sign. I'll make this negative, and I'll make this negative, and this negative will become a positive. Now I'm adding 2/3 xy squared plus -1/2 xy squared. So I have 2/3 minus 1/2 xy squared minus xy minus 4xy. This is -1 minus 4, that's minus 5xy, and plus 2x squared y plus 5x squared y is plus 7x squared y. Now I just need to deal with these fractions. I need to make common denominators so that I can combine these fractions. I have 2/3 and -1/2. And to make a common denominator, I need to multiply each one of these times 1, written in a way that's convenient so that I can make a common denominator. I need to make the denominator 6. So I will multiply times 2/2, which is another way to write 1. I can always multiply times 1. And I get 4/6. 4/6 is equivalent to 2/3. It's just looks a little different. -1/2, I'll multiply this times 3/3, which is 1. And I get -3/6, which is equivalent to -1/2. But now I have common denominators. So 4/6 minus 3/6 I can combine, and I get 1/6. So my simplified polynomial after I subtract is 1/6 xy squared minus 5xy plus 7x squared y. Then I ask that you state the degree for your answer. So I need to find the degree of each term, and I'll name my polynomial for the term with the highest degree. This first term has 1x and 2 y's. That's 3 variables, so it's degree 3. The second term has 1x and 1 y. That's 2 variables, so it's degree 2. And my third term has 2 x's and 1 y. That's a degree 3. So I would say that this answer is degree 3. Another way that you can combine these is by using grouping. This particular method, stacking them up like this, will be helpful in later lessons that we do. We will divide polynomials, and when we do that, you'll have to line these up this way. But you can also add or subtract by grouping similar terms, like terms. Here, I need to distribute this 2 into the second group. Notice that I'm adding, so I don't change the signs of anything, but I will have to multiply each term in the second group by 2. So I can rewrite this as 12xy minus 6x squared plus 2y squared. And you can either line them up as we just did in the previous example, or you can find the terms that have the same variable sets and match them this way. Make a little code for yourself so that you know which ones go with which. Okay. So you go ahead and combine those either this way or by lining them up, combining like terms. And you can pause this for a moment and just see what you get. This is what I got when I combined the two polynomials. Notice that I always add the groups here. With this last group, I had a -5 and a -6, and I still added. I put the sign with the number. And my answer is a degree 2. You will need to be able to multiply binomials, excuse me. Here we have a constant times 2 binomials. So to start this, I'll need to multiply the 3 into either the first group or the second group. It doesn't matter which one you multiply the 3 into. I'll use the first one that's right beside the 3. I would then change this to 3x minus 6 when I distribute here. Okay, so this is rewritten. I don't need that part anymore. To multiply binomials, you can use FOIL or you can use the box method. I'll use box method first. With box method, you put one of the binomials on one side of the box and the other on the other side of the box, and then you multiply. 3x times 4x is 12x squared. Put your products in the boxes. 3x times -5 is -15x. -6 times 4x is -24x. And -6 times -5 is positive 30. On the diagonals, you'll find that you have like terms. You can combine. Here I have -24x minus 15x. That's -39x. And the other two boxes, I don't have anything to combine these with. I don't have another x squared term. I don't have another constant. So I just bring these down. Here's my multiplied, simplified polynomial. And then you state the degree of the answer. This term is degree 2. This term is degree 1. This term is degree 0. So I would say that my answer is degree 2. Some people don't use box method, they use FOIL. So if you would prefer to use FOIL, that's fine. I'm going to use this 3x minus 6 along with the 4x minus 5. So really it doesn't matter what order you multiply these in. What's important is that each term is multiplied times each other term, so that everything is, each piece is multiplied times each other piece. We say FOIL just to make sure we get all of them. So, and that stands for first, outer, inner, last. So the first term in each group is multiplied together. I have 3x times 4x. I will always add my groups. If there's a negative, I put it with the number. So first, outer, that's 3x times negative 5, plus inner, that's negative 6 times 4x, plus last, that's negative 6 times negative 5. I get 12x squared minus 15x minus 24x plus 30. And I combine these middle terms and I get the same answer that I got over here with the box method. And it's still degree 2. So you use whichever method is more comfortable for you. I don't think you did these in Algebra 1. So if you didn't need to write anything down yet today, please make a note of this. And I feel like when you multiply a binomial times a trinomial, that it's simplest to use a box. It doesn't matter if you have a tall box or a long squatty box. You'll get the same result. Okay, whichever way you make your box is fine. There's not a wrong way to make a box. Somehow my box always turns out to be this kind of long, flat, squatty box, but it won't matter. So I'm going to use my standard short box here. And I multiply, just like I did with a 2 by 2. I have x times 3x to x squared. That's 3x to the third power. I have x times 5x. That's 5x squared. And x times 1 is x. Negative 3 times 3x squared is negative 9x squared. Negative 3 times 5x is negative 15x. And negative 3 times 1 is negative 3. I can combine on the diagonals. I have negative 9x squared plus 5x squared, that's negative 4x squared. And I have negative 15x plus x, that's negative 14x. 3x to the third, I can't combine with anything. Negative 3, I can't combine with anything. So this is my simplified, multiplied answer. And this polynomial is a degree 3. If you'd rather not use a box, that's fine. You can also kind of modified foil these. It's not exactly foil because there's a middle. It's not just outer and inner. It's this first term times all 3 in the second polynomial, and the second term times each of those, and then combining like terms. And if you prefer to do that, that's fine. You have some paper and pencil practice to do. Please do that, and then there's a check for you in Delta Math.